Hi everybody, I'm Matt from Megalomobile, and today I'm going to be showing you how to create your very own animated controllable character just like this one from scratch. We're going to make our own assets, animate them, and automate the boring bits like blinking. And we're going to move your character with user input and have full control over the sprites and animations from script. All the links are in the description, and I think you're really going to get a kick out of seeing your creations come to life. If you like what you see, please hit like, please hit subscribe, and let's get started. Right then, let's get into it. The first thing you're going to want to do is choose an art style. I've made my guy to look like a South Park character. This is because I'm a fan of the show, and it's also going to make my life a lot easier when it comes to animating it. You can make yours look like anything you want it to, but keeping the number of moving parts to a minimum will save you some time. Part of that style is that everything looks like it's made from construction paper, so I'm going to use the Pixabay to find a free asset I can use. The texture of this paper looks perfect, so I'm going to import it into Pixlr, where you can see I'm using my buddy Butters here as a reference. Adjust the saturation to remove the color from the image. We're going to be using Unity to control the character's color anyway. We can also resize the image to something more manageable. I want my character to look good in HD, but it does not need to fill up the whole frame. So I've made his height 540 pixels and based his width off the aspect ratio of my reference. You can then cut out all the parts of the body and start to build a sprite sheet. Make sure the background alpha is 0, and I recommend giving each body part its own layer, and then giving each layer a name. It makes this much easier. Arrange each part of the character on the sprite sheet, making sure that there is enough room for an imaginary rectangular box around each body part that requires individual movement or color. In order to give my character that authentic construction paper feel, I've also added a small touch of shadow to the components using the layer mask feature, and I think it looks really nice. I wanted my character to be able to blink, so I put the eyes and pupils on a separate layer. I also made an assortment of mouth shapes, some open, some shut, so my character can talk. I've also added some detail to his shirt and adjusted the brightness and contrast to make the sprites easier to color. Once you've finished your sprite sheet, save it as a PNG file and you're ready to import it into Unity. For this project, I'm in 2D mode with an orthographic camera. In the inspector, set your sprite mode to multiple and open the sprite editor. Here, select slice in the top right and then slice again to automatically make individual sprites for each of your components. If any of yours should move together, like my pupils here, you can manually adjust the boxes. Drag each body part onto the scene to automatically create new game objects and start to build your character. Again, I name each game object so I can keep track of it. For each body part game object, use the inspector to access the sprite renderer. You can set the order in the layer to determine what should render in front of what. Now that your character is assembled, you can use each game object sprite renderer to adjust the color of the sprite. Using uncolored sprites lets us have more control as we can change the color of the character easily from the script. My guy is looking a bit bold though, so I'm going to quickly make him some hair. Now that his head is looking a little warmer, we can make some basic animations to access from a controller script. I would like for him to be able to walk from left to right, wave both of his arms independently, and blink at random intervals. I'd also like him to dance with excitement. To make an animation, you select the game object that you wish to animate, select the animation tab, and then press the create button. I like to save the first animation with no changes so that I have a base state that I can return to. Then I create another animation from this little drop-down menu on the left. I only really need 2 positions for the arms, in the air and resting, as the art style is a bit choppy. For smooth animations, you can use keyframes on the timeline, and Unity will figure out the bits in the middle. To add a keyframe, I select the arm from the menu, and I select that I want to be able to change the transform position and the transform rotation. If I place a keyframe at 0, half a second, and 1 second, then make changes to the middle keyframe, you can see that Unity guesses what the middle part should be. You can make this more accurate by moving the pivot points, but as this is functionality I'm not really going to be using, I don't worry about it. I've deleted the extra keyframes so that the arm is either up or down, and I can now take a look at the animator window. We want to stay at the rest position unless we press a button, so click and drag to create a link and add a boolean called arm up to the conditions. Selecting the linking arrow allows you to make changes to the exit time and also choose the exit conditions. We only want to move to the second animation if the arm up condition is true. If it is false, we want to return to the start position. The full body animation is achieved by having an animator on the puppet. As the other game objects are children of this game object in the hierarchy, they move with the same motion. The animation is completed in much the same way, and I have allowed some automated animated frames in between the keyframes. Again, access the animator and set it up in the same way. This time the Boolean condition is called walking. Remember to untick the has exit time box and make sure that the blue lines in the transition window are vertical and do not overlap. This will prevent your animations from bleeding into each other. Now that we've got our character all set up and ready to go, let's dive into some code. It's only going to take a few scripts to get the functionality that we're looking for. And the first one's really simple. It's just a blink script to get the guy blinking. So first of all, I'm going to set up a public sprite and would call it iWhites. Then I'm going to set a second public sprite and call it iBlinking. Next, a public game object for the pupils. And then a private float for a timer. And another private float for the blink speed. I'm also going to need a private sprite renderer, and I'm going to call that sRenderer. We're going to be using the timer float to time the gaps between blinking, and the blink speed float to randomize the time between blinks. So we'll create a new method, we'll call it a private void, because it doesn't return anything, randomize blink speed. And that's just going to take the blink speed, and it's going to do random.range between 2 and 6, so between 2 and 6 seconds. Now, in order to create a wait between the eyes blinking and returning to normal, we're going to use an eye enumerator, and that's going to be called blink eyes, and that's going to yield return new wait for seconds 0.1f. That's 0.1 float or 0.1 seconds in this case. In the update, we'll say if the timer is bigger than blink speed, do this. But of course, we don't want it to keep doing this. We need to find a way to prevent the code from continually iterating over the same section. So what we'll do is reset the timer to 0, so it starts counting from the beginning again. That way there's a time delay before it tries to run the code again. We're going to randomize the blink speed, run that method. So then we're going to take control of the renderer and change the sprite, and we're going to change that to eye blinking. And then we're going to get the pupils and get their component to the sprite renderer. I'm going to say sprite renderer dot enabled equals false. So when the eyes are blinking, the pupils disappear, because otherwise they'd be sitting over the eyelids and that would not look very good. So next, we're going to say in the start method to get the renderer, and we're going to get the component that this script is attached to, and we get the sprite renderer of that. So that just means we need to set this as a, we need to add this script to the eyes. We're also going to set the timer to 0. And then in the blink eyes script, once the timer's up, we're going to say, great, well, set the render again to the whites of the eyes. And then we're going to get the sprite renderer component of the pupils, and this time we're going to set that enabled to true. Finally, we need to call IEnumerator blink eyes in the update method. So we do that by saying start coroutine, and then in the brackets, blink eyes, open brackets, close brackets, semicolon, and then we're going to say that the timer plus equals time dot delta time. Then we test our code, and it's not working. But why isn't it working? Well, the reason's pretty simple. It's that we haven't set our public game objects and our public sprites in the inspector. So we're going to go through and do that now by dragging the iWhites sprites onto the iWhites and the blinking eyes onto the blinking eyes, and then taking from the scene, we'll grab the pupils game object from the left-hand side and add that on as well. And there he is, blinking away. One thing I have noticed, though, is that his eyes are blinking a different color to his skin. And the reason for that is that we haven't assigned the color for the eyelids. It's taking the color from the eyes themselves, and they are white. So there are a number of ways that we could look into fixing this. So I'm just going to add a quick script to the head, and I'm going to call it skin color. And skin color is really simple. All it's going to do is have a public static color, and I'm going to call that skin. And then a public sprite renderer. I'm going to call that my renderer. Now on start, I'm going to set the public static color skin to the color of its renderer. And because it's static, that's easily going to be accessible in code from any other place. So here I can just say srenderer.color equals skin_color.skin. And over here for the IEnumerator, once it's finished blinking, set the color back to white. Nice and easy. All you need to do now is attach the head game object to the skin color script. It will take the value of the renderer, and now when the character blinks, his eyelids are the same color as his skin. Now, the final script we're going to add is going to give us some keyboard control over our characters so we can move him around and make him perform all the actions that we want him to. However, when I was setting this up, I made a slight mistake. I would normally have recommended you put the script on the puppet. However, in order to get it to work, I actually had to make a new game object, and I called that puppet container, and I made that the parent of puppet. So everything sits within puppet, which sits within puppet container for me. You may not need to do this. And then I went ahead and added a Rigidbody 2D to the puppet container so I could move it around. To set up the Rigidbody 2D, set the body type to dynamic and then set the gravity scale to 0, because if you leave it at 1, the character will just fall off the bottom of the screen when you hit play. Right, let's get started on the final script. So the last script is the puppet movement script, and this is going to have a public animator attached to it for the body animation. It's going to have another public animator, and this is going to be for the left arm. I'm going to call this L arm anim, and the body one body anim, and lastly, it's going to have a public animator R arm anim for the right arm. So the first thing we're going to set up is the flapping arms. Now, I've got all my movements set up to the left-hand side of my keyboard, the WASD gamer side of things, with Q and E operating the arms. Originally, I did have it set up on the up-down arrows, but I had some trouble as my computer was unable to register more than 2 simultaneously pressed arrow buttons at once, with the third button not registering. And after a little bit of Googling, I found out this is quite common, so I've avoided the arrow buttons for controlling the character, because I do need to have up to 3 keys being pressed at the same time, and I don't want that to cause any compatibility issues. So to get our keyboard input, we go to the update method, and I'm going to start with an if statement, and that's going to say if input.getKey, key code Q, then do this. And this is larm_anim.setBool arm_up true. That's going to go into the animator of the left arm and set that boolean that we made earlier, arm_up, to true. Now, if getKey is false, so the key Q is not being held down, it instead is going to set the larm_anim boolean to false. Now, rather than typing that all out again, I'm just going to copy paste. I'm going to switch out the Q's for E's, and I've noticed that I've got a little bit lost in capitalization there, so I'm just going to quickly fix the R's on R, arm, anim. Now we need to link the animators with the script we just made. So we get the body animation from the puppet, we get the left arm from the left arm, and the right arm from the right arm, drag them, the game objects across onto the script, and the arms come up, but they do not come down. And if you have a look, it's happened again, lost in capitalization. The arm up, false. Both the U and the P are capitalized, and really it just needs to be the U. Because this is a string, it's not going to throw up an error in the Unity editor. So you could spend a while looking for problems like this. It's really worth double checking that you've got your capitalization correct. And look, there he is, waving his arms. Oh, doesn't he look happy? Next, I'm going to implement the dance animation. Now, that's exactly the same as the walk animation, so it'll give me a good chance to test it, only he doesn't move left or right when he dances. If input.getKey, keycode S, and if that's true, I'm going to say that body animation, set the boolean walking to true. And if the S key is not being held down, instead I'm going to set the boolean of the body animation walking to false. Just fix my brackets. And I press down, and yeah, he dances on the spot, and he can still use his arms. Excellent. So to move my little guy, I'm going to need to be able to access his Rigidbody 2D from the script. And to do that, I'm going to add a public game object, call it puppet container, and then I'm going to add that from the editor, the game object, grab it and drag it across onto the script. That way I can access it from in code. Now to make it move across the screen, I'm going to say if input.getKeyDown keycode A, that's the left direction, then I'm going to go to the Puppet container that we've attached to the script and get the component, the Rigidbody 2D. I'm going to add a force of -200 in the X direction. And I do that by saying new vector2, and then in brackets, -200, 0. The 0 being how far it would move in the Y direction. I don't want it moving up or down. Now you notice that for the movement, I use get key down. Now that only triggers once. That triggers when you press it. However, whilst you're holding it, I also want him to do his little dance animation, the little walking around animation. So I also put if input.getKey, key code A, and body animation, so I'm going to set that bool to walking to true. And of course, I want that animation to stop when you lift up the key. So if input.getKeyUp, key code A, body anim.setBool, and I make the walking false. Now, when I lift up the button, I want to stop the motion in the X direction. So I'm going to provide another force, which I'm going to add to that Rigidbody 2D, only this time it's going to be in the opposite direction. So instead of -200, I'm going to say 200 in the X direction, and that should stop him dead. And I'll just test that, and yes, that worked. So as that worked for him moving left, just as well, reuse the same code I've got here, copy paste, make him move right. So instead of A, it's going to be D, and I'm also need to switch around the 200 and -200, so now he's going +200 in the X direction. He's going to move right. He can move left, he can move right, he can dance on the spot, he can still wiggle his arms. He's really coming together. So next I want to implement a talking animation, and I'm going to do this by randomizing the sprites that are shown over his mouth when I press a button. So I'm going to create a public sprite array, and I'm going to call it mouth closed shapes. I'm going to create a second public sprite array and call it mouth open shapes. You can populate these arrays with sprites by adding them from the inspector. I'm also going to need a timer. Whilst the sprite animations are cycling, there does need to be a short gap between the depiction of each sprite. So in order to create that delay, I'm going to make another enumerator, and I'm going to call this one talking. And it's going to yield return wait for seconds 0.2f, so for 0.2 seconds. Then I'm going to create a button to start playing the speech animation, and that button's going to be W. So same as before, if input.getKey keycode.w, do something. An issue that we're going to have to circumvent is preventing the animation from cycling infinitely fast, really, really fast. And the way we're going to do this is with something as a Boolean switch, essentially. And I'm calling this one do once, and initially setting it to false. So if do once equals false, the first thing I'm going to do is set do once to true, and that traps it from entering this this loop until do once is false again. So I'm going to create a basic random int. I'm going to call it A and have a random range, and it's going to be between 0 and mouth open shapes dot length. Now, mouth open shapes being the array where we're storing the pictures, so it's going to cycle through each picture of an open mouth. So it's going to count how many open mouth images there are, and it's going to say, right, well, pick a random one of those between 0 and however many there are, and give me that integer. And I'll do exactly the same for int b, random range, 0, and this time it's the mouth closed shapes.length. The reason I've separated them into open and closed is because I only want to transition from open mouth sprites to closed mouth sprites. This will help to keep the illusion that our character is talking, despite the fact that his lips never actually line up with the words that are being spoken. I create a private bool and I call it mouth open. If the mouth's open, then it's true. If the mouth's closed, it's false. If the mouth is open, do this, else do that. And what I want to do is create a public sprite renderer, and I'm going to call this one mouth renderer. So if the mouth is open, mouth renderer dot sprite, so the sprite which is being rendered at the moment, equals mouth closed shapes location B. So what's happening here is it's taking a random number between 0 and the total mouth closed shapes, and then it's selecting a random number there, and that's giving a location in the array as to where that sprite is. So that when I say mouth renderer dot sprite equals mouth closed shapes location B, is going to pick a random sprite from the list of closed mouth sprites that you provide. I then set mouth open to false because once you've rendered the mouth closed sprite, the mouth is closed. I want the opposite to happen when the mouth is open. So of course I set the mouth renderer.sprite to mouth open shapes at location A. And of course that's the random location that we created earlier. And then I set the mouth open to true because of course once you've rendered that open mouth shape, the mouth is open. Then I need to initialize the coroutine. I say start coroutine talking, and that starts the 0.2 second timer. And in the coroutine there, where it says I enumerated talking, I set do wants to false. So of course it can enter the condition again to change the sprite if you're pressing the button down. That means that it doesn't cycle infinitely, and it does wait that 0.2 seconds. Of course, it should be yield return new wait for seconds. Now there's a couple of errors in my code. I've missed a couple of brackets, so we're just going to add those back in. Now you can head over into Unity and set up your arrays. On the Puppet movement script, you can see that your array has appeared. It says mouth open shapes, size 0. Well, we've actually got quite a few mouth open shapes. I've got 1, 2, 3, 4, 5, 6. So I'm going to put 6 in the size there, and it's going to give me an array with elements between 0 and 5, because of course in an array it starts counting from 0. I can then drag and drop the pictures of the sprites into each location. I also need to add the mouth renderer. And if I test the scene, you can see that it's working really well. He's opening his mouth, he's saying something. I'm not sure what it is, but it certainly looks like he's talking. And of course, all the other buttons are still working too. There's only one final animation I want to include, and that's of course his little dance, and that's going to be really easy to implement. So head back over to the Puppet movement script, and we're going to add a few lines to the start here. So I'm going to pop in a public static bool, and I'm going to call that happy face, and I'm going to make that equal to false. Then I'm going to add a public sprite renderer, and it's going to be called an eye renderer. Another public sprite renderer, pupils renderer. Public sprite, eyes open. Another public sprite, eyes closed. And a final public sprite, pupils. What we're going to do then is head over to Unity and plumb the public bits in, everything but the static bool, which isn't something you set in the inspector. So open up the Puppet, which is where the Puppet movement script is hiding, and you can add on the different bits here, the eye renderer, pupils renderer, take the sprites from the bottom here, make sure you select the right ones, and get the pupil sprite from the bottom as well. Back in Puppet movement, we're going to add an extra line to, well, a few lines really, to the S button, and that's to change the sprites which are rendering on the eyes and things like that. So we're going to say the pupils renderer and set that to null, so the pupils disappear. Get the eye renderer sprite and set that to eyes closed, so it's that X that we were looking at earlier. Get the mouth renderer sprite and set that to mouth open shapes 0. That's the big happy smiley face with the mouth open, and then set happy face to equal true. We're then going to go on the key up to set the pupils renderer.sprite to pupils. So now the pupils are back. Get the eye renderer sprite, and we'll set that to eyes open. And also the mouth renderer sprite, and we'll set that to mouth closed shape at 0. Of course, that's the just the plain smile. And then we'll set the happy face to false. For a W here, one of the issues I was having was that the plain face wasn't returning every time, so I'm just going to quickly add a bit of code in here to say that if input.getKeyUp keycode W it registers, then the mouth renderer.sprite is going to be mouth closed with the little smiley face. Now, the reason we made the happy face a public static bool so we could easily access it from the blink script, and to prevent the eyes from blinking whilst he's got the happy face on, we're just going to wrap the timer plus equals time delta time in a little if condition which says if the happy face is not showing, then of course carry on with the timer, but if it is showing, don't continue with the timer, And of course, that will pause everything there until you let go of the button. So I'm going to quickly scroll through each of the different scripts. I am going to have links to everything in the description, and it'll be really easy to take a look at the final version without having to come back to this YouTube video, but I will include it on screen just for reference sake. Lastly, let's take a look at the final result, because I think it looks great. I've got my character here running around in the mountains. He looks exactly like I pictured him, and it's come out perfectly. If you do follow along and end up making one yourself, then I would love to see the final result. Please do send me a link. Thank you very much for sticking with it to the end. I hope you learned something. I hope you enjoyed yourself. And if you did, please hit like, please hit subscribe, and please check out my previous video for a fast, easy, parallax animated space scene that you can use in your own games. This channel is very new, so every subscriber counts, and I'm really looking forward to hearing what you have to say in the comments. See you next time.